In this video, we will be talking about coming up with a research plan, a project plan. So what is it that you want to do? One of the first things, I introduced to you in the last video is basically how to find a research article. Now, what we want to do is we want to come up with a plan. What is it that we are interested in? So the best way to do this is to find some files, look for the peer-reviewed research, look and see what is available and what's out there, read it, review it, and think about it. So this is kind of the first part of that process, and looking for papers. And what I'm going to do now is we're going to talk about different types of papers, and then also try to kind of go through maybe how you might want to start to read through a paper, because you're going to read through journal articles and peer-reviewed papers maybe differently depending on the type of paper that it is, and also what the purpose is, what it is that you're doing with the paper, and why you are looking at it in the first place. During the semester, you will be discussing two different articles. Now, this is a virtual class, so what we will be doing for those is that you will be pulling out the information from these articles, and you're going to make a video like this, similar to this, and present that information virtually. But a lot of times what different science labs will do, research groups will do, is they'll get together and they'll have certain papers. They might individually select papers, or as a group, they'll all read through and discuss a paper. And they'll talk about the pros and cons for what they did. They'll talk about their analysis, their methodology. Specifically, they'll look at figures in the paper and talk about the results. And usually that'll lead them to possibly think of different ideas that they could do in their lab, or different alternative approaches that they might use to get to a similar question. So this is something that we'll be doing, but what I want to do is I want to talk through the different types of ways that we can read through papers. First, I'd like to talk about how to read an article, and one of the big things to begin with is it depends on the type of article that you're reading. There are really two major types in sciences. There are the primary research and there are the research articles. So if we have a review article. So the review articles are mostly involved in kind of bringing up, it's a review of all of the information about a certain subject. So if we're looking at using patient-derived induced pluripotent stem cells to identify Parkinson's disease, these authors have looked through the literature and looked through the most up-to-date information, and this was published in 2018, so now this is out of date, and then you could write a new one, from 2024. What are the newest things that are happening? So this is an article that they've pulled information and resources. A lot of times in these types of review articles, now this one clearly says purpose of the review, so you can see that it's a review when you open up the PDF. And I'll show you how I found this on, you can find these pretty easily on PubMed. But sometimes it's harder depending on the database you're looking for to identify. But most of the ways that you can identify the review articles are if there is not research done in that paper. So if you go to a methodology section and there's no methods, and it only describes other people's results and other data from other sources, that's how you would know it was a review. You would also be able to, sometimes it says it on there, but also a lot of times there will only be tables. There won't be any figures of actual information or data that were collected. Now, primary research, what that means, that's a little different. That is, these authors have set up experiments and they went through the experiments. They're not just reading other people's information and bringing it together. They're actually doing the experiments. And a lot of times you'll see data. If you bring in up the PDF, it'll say associated data, supplementary materials. That's all of their information. That's all the data that they collected, and they're analyzing it. So it's a little bit different. And the purpose for these are different. Sometimes you want to put this type of paper together so that people that are trying to get into the field or understand the field and the current status of the field can go to these types of review papers and catch up and understand. So these aren't bad things to start with when you're doing your research and seeing if there's a certain area that you're interested in. You can go and look at these and kind of get an idea of what was happening But then you want to fill in these review articles with actual primary research and understand what's happening at a deeper level as well. So if we're looking for a review or a primary research article, for example, if I go here and type in my name, I have some articles that I have written. You can, in at least PubMed, you can search for review articles specifically. And here I, with Dr. Ebert, wrote a paper about using stem cells for drug screening, for example. So this was an article. It's not freely available, so I'm sorry you can't open it up at the moment. But this is basically tells you this review. It'll be pretty obvious, and there are other people's data, other information that we used to kind of provide an overview at the time of that information. So that was a review paper. If you want to just do full text articles or full free text articles, these are other. I'll do free ones so you can open it up right now. These are other primary research articles, and you'll be able to see that when you go in to look at the article. You'll actually see some actual data in the experiments, and typically if you look down here, it's not going to say this was taken from some other research article. These are data from the paper, and that means it's primary. It's primary research. Ultimately, you want to ask yourself, what are the goals for your reading, right? So if you're just starting out, sometimes those review articles can be really nice to just get an overview of the field and where the interesting research lies, or the different opportunities for understanding these types of things. But then once you look into this, and once you have to start to develop your process, your methodology, and the things that you're going to do for your paper, you're going to maybe have to start looking at some of these other types of papers. What is the purpose of why you're looking into the paper? Are you trying to identify a specific protocol or a specific process? You're trying to look and see how people analyze the chemical question you're interested in. Are they using HPLC, GC mass spec? Are they using some other instrumentation or process that you need to learn more about? You might need to look more closely at the protocols. Are you just looking to find data that supports your work, or to suggest that the area that you're interested in looking at makes sense? That might be another thing that you're doing. You're just looking at their GC mass spec data to see, oh yeah, they're identifying this compound I'm interested in. Better understanding of techniques. So again, model systems or the tools that they're using, how different techniques are presented. So a lot of the time, what we're going to see in primary research articles is there'll be an abstract, first of all, which is usually the abstract will be missing from a review article, because it's the point of that abstract is to tell you, give you a general idea of what was found in the research. So this abstract typically is only found in the research type of primary research articles. Both would typically have a background and introduction section where they're going to give you some ideas of what is in the paper. They'll provide some background, some references to other work that is related to the area that is being discussed. The results section, that would be typically missing from a review paper. They would just mostly be a big, huge background introduction that might be multiple pages long. So the primary research is going to have results, not just tables, but typically some things where you might actually see some of the data that were generated from the experiments. They'll also have a methodology section or methods section where they'll describe in some detail or provide links to more detailed ways to run the experiments. And then there'll typically be a section where they'll go through a discussion and discuss the results. So this is more typical of what you'd see in a primary research. If it's a review, it's mostly going to be just kind of background introduction. These other sections are going to be typically missing. So another way to kind of identify between those two types of articles. This is typically the order of primary research articles. The order might change, the results or the methods or something might go somewhere else, but this is typically how it is organized. Now, just because it is put in this way does not mean that you should or need to read this chronologically. You do not need to start from the top and go all the way down through the paper. again, it really depends on what the purpose of your reading is. But I'm going to walk through just an example of a paper and just kind of highlight some of the information or ways that you might go about looking through these research articles. So this is a research article from PLOS One. It clearly states it's a research article. It's going to have those typical areas that I was mentioning. This is the title here, the authors, and then just where the authors are coming from. So there's a lot of authors on here with a lot of different places where, institutions that they're associated with. So a really great place to start with these are to read the abstract. The abstract is kind of like an overview of everything that is in the paper. So they're going to give you a really extremely brief introduction. They're going to basically usually tell you a little about the methodology that was used. They're going to give you some of their data, their highlights of their data, and then usually end with some type of overview of, so for example, this study provides evidence that EMS iPS cell lines are a useful tool for screening drugs to treat EMS and investigate the mechanism for underlying disease. So, okay, great. So right away, the abstract, you might read the first few sentences and maybe skip to the end. Is this even worth reading, right? So that's the question. Is this something you want to read? Do you care about EMS iPS cells? Do you even know what they are? Okay, great. Let's come up here and okay, then that's defined. So we're gonna have to look at what it is that they're telling us. So this looks like a useful tool. Oh, I'm interested. I want to read a little bit more. What are the tools, or how are they using these tools? All right, so that's where you want to start with any paper. And a lot of times the abstracts are given to you when you're doing your searches, and you can read through them before you even download the PDF file. So that's the nice thing about an abstract. It gives you an overview, a very quick overview of the entire paper. So you always do actually want to start with the abstract. When you are reading, this helps us get an idea of if this is worth continuing into the paper more deeply. So you might, when you're reading this, want to highlight certain terms and things that you may or may not be familiar with. Maybe you do or don't know iPS cells. I like to highlight some of these, especially things that are used often, acronyms. Those get science loves to use acronyms. So highlighting those right away and getting to know what is important, that can be valuable. Highlighting certain areas or writing notes down somewhere so you keep track of what the big picture ideas are. These will usually be in your abstract, and this is a good way to kind of start with even your annotated bibliography. That can help with that as well. So what I would recommend usually when you start reading papers, if you're beginning this journey and you're not quite sure what you're looking at or what you want to study, you usually want to start with the abstracts to help you choose a paper if this is interesting. Then go into the background and introduction to gain knowledge. And I would skip typically the results and any of the methodology and go right to the discussion, because it gets to the gist of the work. It gets to, they're going to help you interpret the data. They're going to give you kind of what they saw and which figures are important for which purposes. And then finally, you can go back to the protocol results after you've understand how they've interpreted it. So again, when you're beginning, that's a good way to do it. Rather than, again, straight through the paper, you might hit the methodology, and then it's just a bunch of text that isn't going to make any sense to you at this point. So it's probably not worth it yet until you understand how it's used and where to go with it. Once you're a little more comfortable, you might start to look for the abstract, and then you could skip the background because you've read it 3 or 4 or 5, 10, 20 times already, right? So the background isn't something you're gaining knowledge in anymore. Why would you read that? You kind of basically know what's going on. You might read the last paragraph of the background just to see where they're going with it and how they're going to utilize that. But typically I'll skip that information once I become more comfortable in a field. And you can go right to the discussion of the work to get a gist of what the results are telling them and how they're interpreting it. Then I'll go back to the protocol if that's what I'm looking for specifically. Maybe I just want to read the paper for the protocol and see what they're using it for. I see a cool figure I can go to the discussions. I might go to the results and look at the figure. Then I want to know how they made it. So I'm kind of going through and finding specific things that are interesting to me. And if I see results that's interesting, maybe I want to use that in my own work, I would check out the protocol. Maybe I don't, I'm just interested in the results, then I can just keep with that. So every single paper, you don't need to read every single word of that paper. Sometimes when you get further in your research, you're just looking for certain things and you can select what you want out of it. You don't have to use the entire paper, and you might not read the whole paper. One thing that you'll notice in papers, and it is helpful to do, is in the introduction, if you ever do skip something and go into the results, a lot of times the abstract or the introduction will kind of list all of your acronyms for you as well. So here we have the EGF, the fibroblast growth factor receptor, FGFR1. We had EMS earlier, MPD. So you'll see a lot of these acronyms, and they start to help you look and understand what's happening. So you might want to highlight these or make note of them so you can kind of make sure that you are understanding what's happening. So these just tell you a lot of information, and you, again, maybe want to highlight the acronyms to help you keep track of those things. So the introduction gives you some information about the mechanisms, about the model system, and these are all part of that first kind of part of the paper. Again, I mentioned I usually skip the results and go right to the discussion, or I recommend students do this so that they can understand how these results are being interpreted, and then they can always go back to the results. So for example, what we can find out, we're only able to establish that these one clone that tells us, and then further studies are required. So this tells me that they're just beginning this process and they have more work to do. Further in the discussion, it says, okay, we have some information about table 1. So then maybe I'm interested in what they're saying here about these CD34 positive cells, and I might just go on to table 1 and see what that says. So I would go back to the results, look at the information, and find that there. You might also see supplementary tables. You might need to go back out to the website and find that information. Sometimes they're linked here. You might need to check supplemental figures, supplemental information. You might see a word that you don't understand. Maybe you don't know what transduced means, or BM microenvironments. You might need to look some things up. Don't expect to understand everything that you're reading. Maybe you say patients with de novo acute leukemia. What does de novo mean? I don't know. Maybe I need to search that up. So don't expect to read research articles and understand every single word and every single term. You very likely might need to look up what de novo means and rewrite what that translation is for you, and then reread the sentence to make sense of it. So science can be a whole nother type of language, and there are going to be terms that you don't understand. That's fine, but you should expect to go out and have to Google search some terms or go out and do some more research to understand it. You might need to go to the supplemental information. So just something to be aware of. It's not just going to make sense all the time through the first reading. Just to show you, a lot of times there'll be supplementary information that doesn't get put into the main paper. It doesn't make it into the main paper typically because there are limits that the paper publishers are willing to put in terms of pages for each paper. But there's really important documented information that need to be included so that the reviewers, for example, trust the work. So karyotyping, this just looks at the DNA of the cells and makes sure that they're normal and that the cells didn't pick up any genetic errors. So different primer sets or different fusion proteins. So they might have stuff that you may or may not want to look at. And as I mentioned earlier too, a lot of times in the discussion section, they'll identify and pick out certain figures, pivotal figures to discuss in the discussion session. So this helps you also focus on some of the most important assays that they're running. Maybe figure 1, 2, and 3 are kind of more controls or nothing that's really critical, but the reviewers ask them to put it in there just to prove what they're doing is true and accurate. But the real interesting thing here is figure 4, because they've specifically pulled it out into the discussion session. So that this kind of looking skipping the results and going to the discussion first can help you identify some of the really important figures from these papers. Another area that is helpful in the discussion and sometimes is where they'll talk about some of their reports or some of their information, and they'll help you identify other papers that you might want to look at. So a lot of times, and there are different formats for this. Sometimes they're superscript, sometimes they're in parentheses, these are boxed, but these are references, 10, 11, 12, 13, 14. You can click on those, and usually it'll take you to the end of the article, to the references pages, and that maybe this 10th reference is the one that's going to be really interesting and you're going to be your next read. So these discussion sections also a lot of times will lead you to, in the background as well, will lead you into areas where you might want to do some more digging and more research. So this is the end of the discussion section of this paper. And honestly, usually what I do first when I'm going to the discussion session, I will skip all of the other stuff and I'll just read the last paragraph of this, right? So if I do that, it usually matches the abstract, but sometimes it gives a little bit more detail and looking for forward-thinking statements that helps to say, what are they going to do next? What is the next thing that is on the horizon? So maybe this was published in 2015. Well, there's 10 more years of research that's been done since this. Maybe I can find some of that information where I'm looking at, oh, look, can I personalize therapies? Maybe this is a term I want to do a search for in my research. Once I've gone through the discussion, maybe I've identified, for example, they highlighted figure 4. I want to look at these data. I want to look and see what they did. I can understand what their process is, how they made them. They're looking at this Geisma staining. Maybe I don't know what that is. Maybe I want to look into it. I can kind of highlight that and say, hey, I'm going to check the protocols for this staining methodology. I want to look at the data, see what's happening. I knew that figure 4 was the important one, so I went to this one. I skipped 1, 2, and 3. Maybe I'll go back to those. Maybe I don't need to. Maybe this is what I'm looking for. So this is, again, you don't have to, my biggest point is you don't have to read this from front cover to back cover. This can be stylized or modified to match with what you were looking for. So I like to go right to the figures, and that is maybe because I have a little more experience in understanding what those data are and how they've been generated. If you're less certain of that, you can go into the text of the results section and not just look at the figures and the figure legends to understand the process. So if you need more information, you might need to go into the results, where these should be pretty bland without any kind of extra analysis that would be in the discussion. But it's more just looking at, oh, look, we looked at these compounds and we noticed it decreased or increased the number of cells, for example. So this gives you more detail that you might need to go into to better understand what's happening in the figures. And again, in the results might be a great section or area to find interesting articles that maybe give you similar types of information, or maybe a different model system or a different technique. But we saw that 10 before. Maybe this is one that keeps coming up, and then it's a interesting paper that has similar kind of ideas in it. Now for the methods section, maybe I don't know what this compound is. I can do more research. I can find information about it. Oh, look, they dissolved everything in DMSO, and this tells us more information. Now, if you're not when you're getting into providing or detailing your methodology and what you want to do, maybe you're going to look at some of these methods more closely to identify the process and how things are going to work. Again, these are built for people that do research, so they will probably have access or understand or be able to ask someone about the staining. Remember I said, oh, that Geisma staining I wanted to look more into. Oh, it's not in the methods. So maybe we need to do our own research and find that somewhere else that's maybe not in this paper directly. For this class, we're creating a proposal for research. We're not necessarily going to go into the lab and do this. So if we don't necessarily need to know all of the details or have to worry about the detail of the concentrations, for example, maybe. If you are planning to do research or you need to look at that specific piece of information because that is what you're going to look at developing, or you're interested in changing some of the processes, then you might need to add that information into your paper. Statistical analysis is often overlooked, but it's an important component of any research paper, especially when there are numbers involved. So something to kind of look at, how are they doing this? Okay, standard deviation, p-values. So just something generally good to recognize and keep track of. One thing you might notice about scientific writing is it's not a mystery novel. You really want to highlight the important points and make it really easy for people to find those. That's why we have abstracts, right? That's why we put all of that important information right up front. We want everyone to know what they're going to read before they read it. So the science is complicated enough without trying to make it a mystery, complex thing. So try to write in a way that makes things the most simple for people to understand. Organize things so it makes it more simple and clear. There are typical methods for organizing things, so just kind of keep with those outlines. Highlight important features, and typically the way that you want to kind of write these things out is you want to start big picture, big world problems, big things that you're going to focus on. You're going to focus in on some of the details. So you're going to funnel in on those details. And then in the end, typically you'll see they kind of branch back out and blow back into those bigger world kind of issues and bigger problems that they can look at. So this is kind of that funneling process to the focus, and then unifying what does their research mean and how does it go back to that big picture idea they started with at the beginning. So hopefully this helps you kind of start with looking at how to read papers and how to think about what we are going to be doing this semester. Start to use this information to generate your annotated bibliography. Start building your bibliography, building your papers up, and this will start to kind of come together once we have our knowledge base developed.